There are 25 rooms in a hotel. Each room can accommodate at the most 3 people. For each room, the single occupancy charge is 2,000 per day. The double occupancy charge is 3,000 per day, and the triple occupancy charge is 3,500 per day. If there are 55 people staying in the hotel today, what is the maximum possible revenue from room occupancy charges today? So 25 rooms, 55 people. Initially I saw only 25 rooms and I said, look, 25 rooms, all triple occupancy, so 25 into 3,500, that's not the answer. And so we're not working like that. And so because only 55 people, so we'll have to have single occupancy, double occupancy, triple occupancy. And suppose we say X plus Y plus Z, the total number of single occupancy, double occupancy, triple occupancy is 25. X plus 2Y plus 3Z is 55, and we want to maximize 2000X plus 3000Y plus 3500Z. I want to maximize this. That's the way of framing this. Right? So X single occupancy rooms, Y double occupancy rooms, Z triple occupancy rooms. Nice, so far so good. Single occupancy room 1 person, 2 people, 3 people. Total number of people is 55. Nice. There are 55 people staying here. What is the maximum possible revenue from room occupancy charges today? So 2,000 into this, 3,000 into this, 3,500 into that. That's what we need to maximize. So this is 4:6:7. And so ratio wise, you divide by. So we are maximizing 4x plus 6y plus 7z. And so x plus y plus z is 25, x plus 2y plus 3z is this, 4x plus 6y plus 7z is what we want to maximize. We have to manipulate this in some form. Right? So the idea is, suppose you have a, let's find some solution and then we work from there. Right? So if you have single occupancy, only 55 people are there. So we can say, hey, suppose I put everything as triple occupancy, I'll have 18 triple rooms and one, so triple rooms 18, single room 1. 18 into 3, 54 plus 1, but there are 6 rooms that are unoccupied. You make nothing from that. That doesn't really work. So we say, okay, let's flip this. Then we'll do triple and single. And then we'll do single and double. That's simply not possible. Triple and double. And the number of rooms is, number of people is 55. So if we have double and single, double occupancy, if everything is double occupied, you can accommodate only 50 people. So only with 2 and 1 we cannot do it. 3 and 1, with 3 and 2, this is possible. Right, so 3 and 1, 18 and 1, it doesn't add up to 25 rooms. So we'll have to figure out a way. If 25 rooms are all single room, will be 25. Every double room adds 2 more people. Every triple room adds 2 more people. I need to add 30 more people. 15 triple rooms and 10 single rooms is one combination. Right, so here, everything were double occupied, doubly occupied, would take us to 50 people. Every triple occupancy is 1 extra person. I don't want to solve the equation. I'm just thinking about it and saying, hey, every room if every room had double occupancy, that means 50 people. We have 55 people. So some had to be triply occupied, triple occupation. That means from 2 to 3, we're adding 1 extra person. So each room that goes from double to triple will increase my number of people occupied by 1. I have 55. So I should have 5 like this and 20 like this. Think about this. 15 into 3 is 45 plus 10 into 1, 55. That works. 5 into 3 is 15 plus 20 into 2, 40. This works. Let's find the charges for this. Triple occupancy is 3,500. Double occupancy, single occupancy is 2,000. This 10 into 2,000. 15 into 3,500 is what we'll make here. 5 into 3,500, 20 into 3,000. 3,000 per day, 3,500 per day. So this is 20,000. This is 60,000. This is 17,500. So this adds up to 77,500. This is 52,500. This adds up to 72,500. This is better thing. Now we'll see, hey, can I shift from this onto something else? And instead of 2 double occupancies, can I put 1, 3 and 1, 1? Is that possible? And if I do that, do I make more money? If I can, then I'll think about it. 2 doubly occupied rooms is 3,000 plus 3,000, 6,000. 1 single, 1 triple is 5,500. So from 2 double occupancy, going towards 1, 3 and 1, 1 doesn't give me anything. Instead of 2 double occupancies, I can shift to 1 single and 1 triple. If I do that, I lose money. So going in terms of the combination for making better money, 1 triple occupancy plus 1 single occupancy is worse than 2 double occupancies. If I have every 4 people, I can make every set of 4 people, I can make more money with this idea where I have double rooms, more double rooms, occupying them with double rooms and not 1 and 3. Right? So if I have single occupancy, 3 of them, 3 single occupancy rooms, and instead of remember, I cannot unilaterally optimize. I cannot say, look, I'll take a triple room, 1 room which has 3 occupancy, break it open and give 1, 1, 1. That's not possible. We cannot do it. Because I have to keep all 25 rooms occupied. If I don't do that, then I'm in trouble. I have to accommodate all 55 people. If I don't do that, I have to do that. That's an automatic constraint. So I cannot arbitrarily remove this. So once I've got this, I'm thinking, can I shift from one to another? Here, I can take 1 single and 1 triple and replace it with 2 doubles. That makes life better for me. So from this, I'll take all 10 singles and 10 triple rooms and make them into double rooms. 2 sets of double rooms. I'll get 20 double rooms and 5 triple rooms, which makes me arrive at this. And that is better. So there's no further optimization from here on in. I cannot shift and move the combination, or the maximum money I can see is 77,500. If you're creating it like an operations research OR problem with equations and variables, this is how we would frame it. And I have x plus y plus z is 25, x plus 2y plus 3z is 55. I'm optimizing for 4x plus 6y plus 7z being as high as possible. And so, and then saying, hey, how can I manage this? How can I figure out a way to maximize this under these conditions? And so, one way of thinking about it, again, I'm not recommending this. I multiply this by 4 and add these two. 4y plus 2y, 6y, 4y plus 3z, 7z, so this is 5x plus 6y plus 7z equals 25 to 400, 155. Right? 4x plus 5y plus 6z is what I want to maximize. I know this. From this, I subtract an x and I want to maximize that, or my x should be minimum. Put x as 0, work with the other two. It's a more mathematical, algebraic way of manipulating this and coming there. Obviously, with software, we can plug it in and get there. The other way of going about it is plug in 1 and 3, 1 and 2, 2 and 3. With 1 and 2, we simply cannot achieve this. With only single and double, we cannot achieve this. So we need to have at least 1 triple room. And so, triple room and single room, triple room and double room, these are the combos. And then we realized that if I have this, taking 1 triple room, 1 single room and replacing with 2 double rooms makes more money for me. So I'll shift from here to here. And therefore, this is a better combo. That gives us the answer. 77,500. Beautiful, delightful question. I hope I've got it right. Consider the quadratic function f of x equal to ax square plus bx plus a having 2 irrational roots, with a and b being 2 positive integers such that a comma b less than or equal to 9. It took me a while to grab this. Right? Ax square plus bx plus a having 2 irrational roots. I thought, could they be 2 equal roots? Equal irrational roots are not possible. 2 distinct real irrational roots. And so I cannot have equal irrational roots. And so that's not possible. So this is not equal irrational roots. So these are 2 distinct irrational roots. That means my discriminant is greater than 0. Otherwise, I won't have 2 distinct real irrational roots. Right? That's the first step. Right? Not just that, because it is irrational, I can say my discriminant is not a perfect square. If b square minus 4ac were a perfect square, then I'll have rational roots. Minus b plus or minus square root of, then my completion of squares works beautifully. Everything gets cancelled very nicely, and I can get rational roots. If I'm getting irrational roots, that means three inferences. Irrational roots, that means the real roots exist, discriminant greater than or equal to 0. Irrational roots, so irrational roots are distinct, so discriminant is greater than 0, not greater than or equal to 0. Irrational root, that means my discriminant is not a perfect square. So I'm looking for discriminant greater than 0 and discriminant not equal to a perfect square. And we know that a and b are positive integers, so 1, 2, 3, 4, 5, both less than or equal to 9, 1 to 9, 1 to 9, a and b. And all of these conditions are satisfied, and then we come back to this. If all such permissible pairs are equally likely, what is the probability that a plus b is greater than 9? First we find out permissible pairs, then we worry about greater than 9. So discriminant greater than 0, that means b square minus 4a square greater than 0, b square greater than 4a square, b greater than 2a. I'm not going to say minus less than minus 2a and all that, positive integers. That's given. So I'm not worrying about b less than minus 2a. I don't care. Already I have too much to worry about, right? Because then I have to say a positive, a negative. Technically mod b greater than mod 2a. But I'm not worried about mod. I'm thinking only positive territory because I know a and b are positive integers. B greater than 2a. Second condition that I have here is b square minus 4a square not a perfect square. Brilliant. B greater than 2a is a very useful constraint because a starts from 1. 1, 2, 3, 4, 5 and so on. So 2a would be 2, 4, 6, 8, not more than that. Because if 2a were 10, b has to be more than 10, that's not possible. So a can take only values 1, 2, 3, 4. What values can b take? If a were 1, b has to be more than 2. So this will be 3, 4, 5, 6, 7, 8, 9. If a were 2, 2a is 4, b is more than 4. So starting with 5, 5, 6, 7, 8, 9. If a were 3, 2a is 6, 7, 8, 9. If a were 4, 2a is 8, b should be only 9. So my possible set of values, a is 1, b is 3, a is 1, b is 4, a is 1, b is 5, 1, 6, 1, 7, 1, 8, 1, 9, 2, 5, 2, 6, 2, 7, 2, 8, 2, 9, 3, 7, 3, 8, 3, 9, 4, 9. Brilliant. Except we have not yet accounted for this constraint. It may make a difference, it may not make a difference, we have not yet accounted for that. Okay. How many pairs are there? How many values are there for b? 1, 2, 3, 4, 5, 6, 7. 7 plus 5 plus 3 plus 1. Nice. So 16 possible values are there for a plus b without accounting for this thus far. We have not accounted for that so far. Obviously, within this, we can have to finally come back to a plus b greater than 9. That I can figure out. That I am confident we can do. So now let's go back to this constraint, b square minus 4a square not being a perfect square. Right? So a is 1. I want to think about 4a square. If 4a square is 4, 16, 3 square is 9, 36, 4 into 16 is 64. This is 4a square. Think about p square minus 4a square. 9 minus 4, not a perfect square. 16 minus 4, 12, not a perfect square. 25 minus 4, not a perfect square. Something minus 4. If it were a perfect square, the numbers are to be very close to each other. Right? So 6 square, 7 square, 8 square, 9 square, minus 4, not a perfect square. So here I have nothing to worry about. Here 5 square minus 16. Straight away I've got one beautiful exception to this. Very, very crucial. This, when b is 5 and a is 2, 5 square, 25 minus 4a square, 25 minus 16 is 9. That is a perfect square. So this equation where 2x square plus 5x plus 2 equal to 0, it will have roots that are distinct and real and rational. It will not have a rational root. So that one is out straight away. Out of our 16, one is out. Right? So 36 minus 16, no. 49 minus 16, 33, no, not a perfect square. 64 minus 16, 48, close but no cigar. 81 minus 16, 65, not a perfect square. 49 minus 36, 13. 64 minus 36, 28. 81 minus 36, 45, not perfect squares. 81 minus 64, 17, not a perfect square. So only one thing goes away. So out of this 16 possibility, one goes away. And A is 2, B cannot be 5. So we don't have 16 possibilities, we have only 15 possibilities overall. Nice, so far so good. Now let us come to this. What is the probability that A plus B is greater than 9? A plus B greater than 9, 1 plus 9 will come. We go to 2, 2 plus 8, 2 plus 9 will come. We go to 3, 3 plus 7, 3 plus 8, 3 plus 9 will come. We go to 4, 4 plus 9 will come. 1, 2, 3, 4, 5, 6, 7. 7 possibilities are there for A plus B being greater than 9. Out of 15, 7 by 15 is a correct answer. Why this question is beautiful is after struggling through a bunch of these things, we could very well end up worrying about this. The correct answer is 7 by 15, not 7 by 16, because A equal to 2, B is equal to 5. That possibility has distinct real roots, but does not have irrational roots. We'll have to not just worry about discriminant being greater than 0, we'll have to be worried about discriminant greater than 0 and not being a perfect square. Brilliant, brilliant. That not being a perfect square exception, super, super good. A farmer has a quadrilateral piece of land with a perimeter of 700 feet. Two opposite angles of that parcel of land are right angles, while the remaining two are not. So it's not a nice rectangle. That will make life easier. So we have something like this. This is a right angle. This is a right angle. These two are not right angles. Let's call this ABCD. The perimeter is 700. So AB plus BC plus CD plus DA is equal to 700. Right. There's a right angle here. There's a right angle here. The farmer wants to do organic farming on the parcel of land. It's all the rage. The cost of organic farming is rupees 400 per square feet. Consider the following two additional piece of information. Right. So to determine the amount of money the farmer needs to spend to do organic farming, which of the following additional piece of information are minimally sufficient? Very interesting language being used here. Saying, can you do this with just 1? Can you do it with just 2? Can you do it with just 1 and 2, or 1 and 2 together, but not 1 alone, not 2 alone, 1 and 2 together? Or can you simply not do it, even after getting all this piece of information? That's our question. So it's like a data sufficiency question. Is the given information enough to find area of this quadrilateral? Right, so I'm going to join this AC. Why am I joining this AC? Because this right angle is a right angle. If I know B and altitude from B, altitude from D, life is simple. The BD seems like a weird diagonal. AC is a good diagonal. Why good diagonal? Because AC carves this into two right angles. I can do half into base into height very easily, get away with it. Whereas BD does not help me much. So I'm going to draw AC so that I can imagine this diagram better. All four sides add up to 700. And let's do this. The length of one of the sides of that parcel is 110 feet, which is basically BC could be 110. Does this help? All three add up to 700. I can even arbitrarily say, let this be 110, let this be 200, 310, let this be 200, 510, let this be 190. This is one set of combination for the four sides. This could be right angle, this could be right angle. Nothing is preventing any of that from happening. If we do this, then we obviously recognize that this square plus this square is this square, this square plus this square is this square, that condition is defied. So we have to worry about it a little bit and then say, hey, nice. Therefore, we cannot arbitrarily put numbers here. So we cannot say, hey, let me put any number that I want. I'll have to find suitable numbers. This is 110. 120 square plus h square, or some number r. The square root of 110 square plus r square, which is nice. So overall perimeter is 700. I don't want to make this ridiculously wildly variant. So what I'm going to do, I'm going to just try out this thing and say, hey, can I put this as therefore 250. 250 square plus 110 square, whatever that number is, I find that here. 360 is gone, 340 remaining. This is x, this is y. X plus y is 340, x square plus y square is this. I can find a solution. So there is one combination. I could put this as 260, I'll get another combination. I could put this as 230, I'll find another combination. For some range, I won't get a combination, but I know that for a bunch of values, I can solve for x and y. And so statement 1, standalone, not sufficient. I just have that as 110. I can imagine this one being 250. This AC square is 110 square plus 250 square, which is x square plus y square. And I know x plus y is 340. 250 plus 110 is 360, remaining is 340. X plus y is 340, x square plus y square is something I can solve and I can get. Maybe for some value of this, there will be no solution. But if there exists for 242.3, chances are it will exist for 242.4. So 110 standalone is not sufficient. Just knowing one side is 110, not enough to answer this question. That's all I want to do. I don't want to find a combination. I don't want to find multiple scenarios. I know that multiple scenarios exist. I'm good to go. So let me remove that condition. Remove this, take this off. Come back and draw my diagram. And go to the second condition. The distance between the two corner points where the non-perpendicular sides of that parcel of land intersect is 255 feet. Very nice. So draw this. This is 255. Nice, brilliant. So this is 255 feet. Now I know that if I put x and y, x square plus y square is 255 square. P and Q. P square plus Q square is 255 square. So I also know x plus y plus p plus q is 700. And so x square plus y square is 255 square. P square plus q square is 255 square. Nice. I know x plus y plus p plus q is 700. So can I now confidently find the area? So now let's assume that we put arbitrarily some x and y that satisfies this. And let me put x equal to 200, y is some other value. Suitably, I can find that. Once I have put that, then I know p plus q is some value. P square plus q square is 255 square. I can solve and get it. Can I now say, if I put x as 210, y as gets a different value, and then solve for the remaining part, I'll get another solution. Then again, multiple values of x, y, p, q are possible that satisfy all of these conditions. X square plus y square is 255 square. P square plus q square is 255 square. 255 is 51 into 5 the whole square. The hypotenuse is 51. There should be some Pythagorean triplet that satisfies this condition with hypotenuse being 51. 51 is 17 into 3. 8, 15, 17 works. So I can imagine 8 into 3, 24 into 5, 120. 120 again 15 into 15, 120, 225, 255 works. 120, 225, 255 works. 120 plus 225, 225 plus 120 is 345. Remaining is 355. These two add up to 355. Square is 255 square. I'll be able to solve it and get P and Q. It's an 8, 15, 17 triangle. I can imagine that working. Right? Nice. Is that the only scenario? And so, is that the only possibility? Suppose hypothetically, instead of 120, 225, I made it 119 and 225.3 or 225.4, such that it works. And very little I shift that. I get to a solution here. That will also shift slightly. That will be another possibility. So it's all telling me that assuming this is 255 and perimeter is 700, hypotenuse for both triangles is 255, still does not guarantee me a unique solution for x and y. And I'm solving for half xy plus half pq. I'm solving for xy plus pq. I'm solving for 2xy plus 2pq. And so if I have x plus y whole square, p plus q whole square, from that I can subtract this. So is that another way of thinking about it to get xy and pq? I know from this, I want to do this. X plus y plus p plus q is 700. I know x plus y whole square minus 2xy is 255 square. P plus q whole square minus 2pq is 255 square. X plus y plus p plus q is 700 square. So if I find x plus y whole square, I can find 2xy. P plus q whole square, I can find 2pq. But I have x plus y plus p plus q is 700. I'm not being told that this is 350, this is 350. This is 345, this is 355. For that different combinations, I'll get different answers. And so I cannot uniquely come back and say, hey, I've got this. Now what do? 1 alone is not enough, 2 alone is not enough. I'm going to say, hey, 1 alone not enough, 2 alone not enough. Let's remove this, let's remove this. Let's put both of them into the mix. We say, hey, one of the sides is 110. Other is this hypotenuse is 255. This I can find. This plus this I know. Once I know that I know this and this, I know that the remaining p plus q I know p square plus q square. I can find 2pq. I can find this. Done. Both put together, I can answer the question. 1 alone, 2 alone, I cannot answer the question. I'll need 1 and 2, both. Or 1 and 2 together only. Not 1 alone, not 2 alone. 1 alone is easy to prove. 2 alone is tougher to prove. We don't prove as much as kind of get a gut feel that it doesn't work like that. 1 and 2 together, it can definitely be. Answer choice E for elephant. A straight line L has the equation y equal to k times x minus 1, where k is some real number. The straight line L1 intersects another straight line L2 at the point 5, 8. L2 has a slope of 1, which of the following is definitely false. So this L1 passes through 5, 8. L2 passes through 5, 8 and has a slope of 1. First thing we can do is find L1 and L2. L1 is y times L1 is y equals k times x minus 1. It satisfies 5, 8. 8 equals k times 5 minus 1. K is 2, or L1 is y equals 2x minus 2. Nice. What is L2? L2 passes through 5, 8. So y minus 8 equals 1 times x minus 5. Y minus y1 is m times x minus x1. So we have y minus 8 equals x minus 5, or y equals x plus 3. Brilliant. We have y equal to 2x minus 2, y equal to x plus 3. L1 and L2, which are the following, is definitely false. So we'll have to draw these two lines and then evaluate each of these. So let's draw these lines. 2x minus 2, x plus 3. X plus 3 is easy to draw. Zero comma 3 minus 3 comma 0. This is L2, y equal to x plus 3. 2x minus 2, when x is 0, y will be minus 2. Draw with a different color. We have all kinds of colors. 0 comma minus 2. When y is 0, x is 1, 1 comma 0. The line. 1 comma 0, 0 comma minus 2. The question now says they both intersect at 5, 8, that we already know. Let's go step by step, find these things. My diagram is probably not the best, it's still fine. The distance from the origin to one of the lines is 3 by root 2. The distance between the x-intercepts of the two lines is 4, y-intercepts of the two lines is 6. line L1 passes through the point 1, 0. Distance from the origin to one of the lines is 2 by root 5. I'm going to go from L1 passes through 1, 0. That is 2. This one. Easiest one to evaluate. Let's plonk it and simplify that. Distance between x-intercepts of the two lines is 4. Minus 3, 0, 1, 0. Minus 3 to 1, 4. That is true. C. Distance between y-intercepts of the two lines is 6. 0, 3, 0, minus 2. Distance is only 5, not 6. So this one is not true. It's definitely false. That's the one we're looking for. I'm going to verify these two as well. And so distance from the origin to one of the lines is 3 by root 2. Distance from origin to other line is 2 by root 5. Let's find this distance from origin. So 0, 0 to this. This equation is 2x minus y minus 2 equal to 0. From 0, 0, distance is minus 2 by square root of 2 square plus 1 square under modulus 2 by root 5. Yes, that works. This equation is x, y minus y plus 3 equal to 0. From 0, 0, distance is 3 by root of 1 square plus 1 square under modulus 3 by root 2. Yes, this is 3 by root 2. That is 2 by root 5. Both of these. This is true. This is true. The only thing that is certifiably definitely false is statement C. In a computer game, each move requires pressing a button. When the button is pressed for the first time as a move, the computer randomly chooses a cell from 4x4 grid of 16 cells and put an X mark on that cell. When the button is pressed subsequently, the computer randomly chooses a cell from the remaining unmarked cells and puts an X mark on that cell. This goes on till the end of the game. The game ends when either all the cells in any one row or all the cells in any one column are marked with X. What are the maximum possible number of times a player has to press the button to finish the game? Lovely. So 4x4, let's draw this. The first X can be anywhere. We want to put maximum number of X's here without having 3 in a row. So without having 4 in a row, without having 4 in a column. So we can go up to 3 in a row, up to 3 in a column. So what am I going to do? I'm going to say, let me max it out. Put 3, 3 in each row and see if I can put 3 in each row without inadvertently falling into 3 in a column. And so if I put 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, I'll have 3 full columns. So I cannot put that. So what am I going to do? I'm going to put these 3 like this. In another row, I'll put 3 to the row, but not this exact same 3. Let me put 1. Again, I want to put 3 in a row. This, but not matching with either one of this, because then I'll have multiple rows that are identical. That means that many cells would have come in so many rows, I'll have a problem with the columns. So let me put here same. Final one, I cannot put here, I'll put here, I can put here, I can put here. For this sequence, where I put it as 1, 2, 4, 1, 2, 3, 1, 3, 4, 2, 3, 4. If you notice, in this sequence, no row has 4 in a row. No column has all 4. I've accommodated this many. The next one I'm putting, I'm maxed out. All rows are maxed out, all columns are maxed out. To put anywhere, I'll have at least one row and at least one column getting filled. So my 13th X, I cannot accommodate a 13th X, impossible. That I know. And 12 I can accommodate. I can confidently mark 13 as the option. Maximum possible number of times to finish it. You cannot press 14 times. You cannot press 16 times. 16 times means it's the last column is being pressed. Last cell is being pressed. Before that, 4 in a row or 4 in any one row or 4 in any one column would have definitely happened. So by the 13th time, I can guarantee that there will be at least one row and also simultaneously at least one column that has 4. That's done. 12 I can do, 13 I cannot do, 30 is the maximum. Another very intriguing question. There are dustbins along a circular path at different places. Ramesh takes multiple rounds of the path every morning, always at the same speed. He noticed that it took him a different number of steps to walk between any 2 consecutive dustbins. Ramesh also noticed that starting from any of the dustbins, it took a minimum 800 steps to reach every second dustbin. On the other hand, starting from any of the dustbins, it took a maximum 1260 steps to reach every third dustbin. Very interesting. So Ramesh has like this 1, 2, 3, 4, 5. I put only 4, 5. And we have 5 different arcs being created. Let's say this is A, B, C, D, E. A plus B plus C plus D plus E is a circumference, the whole thing. We told the number of steps is different. A, B, C, D, E are all different steps, unequal. We know that A plus B is greater than or equal to 800, B plus C is greater than or equal to 800, C plus D is greater than or equal to 800, D plus E is greater than or equal to 800, E plus A is greater than or equal to 800. Any 2 adjacent arc lengths being added together is more than 800. So Ramesh noticed that it took a minimum 800 steps to reach every second dustbin. He is here to go here at least 800. He is here to go here at least 800. From here 800 at least 800. On the other hand, starting from any of the dustbins, it took a maximum 1260 steps to reach every third dustbin. So from here A, B, C, if I add, maximum 1260. B, C, D, maximum 1260. C, D, E, maximum 1260. Pain. It took me a while. Beautiful question. What I did was A plus B is at least 800. A plus B plus C is less than 1260. C is therefore less than 460. Each one is less than 460. Nice. Interesting. I can say A plus B, C plus D is greater than minimum 800, 1600. I'll add up to A plus B plus C, maximum 1260. So this I can find the remaining range. But all that I'm getting broad ranges. Doesn't help. Fine. So at least 800 for every 2 dustbins. Maximum 1260 for every third dustbin. You want to think about it. A plus B, B plus C, C plus D, D plus E, E plus A. Each of them is at least 800. Or if I add all of them, think about this beautiful idea. A plus B, B plus C, C plus D, D plus E. Each of them is at least 800. Beautiful. So if I add all of them, I get 2A, 2B, 2C, 2D, 2E. Together it will be greater than or equal to 800 into 5. Or A plus B plus C plus D plus E is greater than or equal to 800 into 5 by 2. Very interesting idea. Add all of this. 2 times A plus B plus C plus D plus E is greater than or equal to 4000. Nice, brilliant. Very interesting and done. We're through. Why are we through? Because I can do the exact thing the other way around with A plus B plus C thrown in. And so this means I can frame the next equation as ABC, BCD, CDE, DEA and EAB. Add all of this. I'll get 3 times A plus B plus C plus D plus E is less than or equal to 1260 into 5. A plus B plus C plus D plus E is greater than or equal to 2000. 2 cancel. Oopsie. I divide this by this, it's 420. 420 into 5 is 2100. Brilliantly, quite brilliantly, I can get A plus B plus C plus D plus E is less than or equal to 2100, greater than or equal to 2000. Or our man, he does the whole round, he does at least 2000 steps, at most 2100. I'm reasonably confident that it will be greater than 2001 or 2, less than 2097 or something, but the numbers are distinct. I cannot have 5 distinct numbers adding up to this, somewhere the thing will collapse. Right? So, but this is a broad range and close enough. Maybe 2005, maybe it will be 2095, but I've got this. Now the question says, if Ramesh's one step is 0.77 meter and width of the path is negligible, which of the following can be the radius of the circular path? Radius of the circular path, if I know, then circumference is 2 pi r. Right? A plus B, he takes 2000 to 2100 steps. So 2 pi r is between 2000 into 0.77 and 2100 into 0.77. It takes this steps. Pi is 22 by 7, 2 into 22 by 7 into r. This is 20 into 77, less than 21 into 77. This is 22, I can cancel off, make it 2. This will be 11, 7 gets, this will be 7, 11 gets cancelled off. This will be 7, or 20 into 7 less than 4 by 7 r less than 21 into 7, or r is between 21 into 7 into 7 by 4 and 20 into 7 into 7 by 4. 5 into 7 into 7, 7 into 7 is 49, 49 into 5 is 245, 245 less than r less than 21 into 7 into 7, 7 into 7 is 49, 49 into 21, 49, obviously this helps if you have a calculator, 1029 by 4, 250 goes off, 257.25, r has to be between these two. Now let's look at the choices and make hay. Between 245 and 257, brilliant. I really got high on this question. I didn't know what to do. There's too much data, too many stories. But then the idea is the average is more than 400, average is less than 420. Done. That's all. Average distance between two adjacent points is more than 400 and less than 210. Or less than 420. None. With that, we can figure out everything else. 8 employees of an organization have all been rated on a scale of 1 to 50 for their performance. All ratings are integers. The overall average of the 8 employees is 30, while the 5 highest ratings average is 38. The 5 employees with the lowest ratings is 25. Nice. So 8 are there. The first 5, the total is 125. The last 5 total is 190. Overall total is 240. 3 into 8, 30 into 8 is 240. 25 into 5 is 125. 38 into 5 is 190. Which of the following obtained by the 8 employees is definitely false? I'll have to come there. So this is in ascending order. Now I want to worry whether the weights are given to be distinct. All ratings are integers, that is helpful, but not distinct integers. Right? So I can assume the 8 weights to be A1, A2, A3, A4, A5, A6, A7, A8. A1 less than or equal to A2, less than or equal to A3, less than or equal to A4, A5, A6, A7, A8. What can I infer here? If I add these two, 1 to 5 and 4 to 8 get added. So the middle two weights 4 and 5 will get added twice. And so if I subtract this, then 125 plus 190, if I add these two, right? A1 to A8, remember that. If I add these two, sum of these two, it will be A1 plus A2 plus A3 all the way till A8 plus A4 plus A5. Why? Up to A8 plus A4 plus A5. So imagine A6. The first 5 will be A1, A2, A3, A4, A5. The last 5 will be A4, A5, A6, A7, A8. So this A4, A5 will sit on both of these lists and get double counted. So this plus this is A1 to A8 plus A4 plus A5. 190 plus 215, this sum is 315. All 8 put together is 240. Quite beautifully, we've got the middle two adding up to 75. Brilliant, super useful. Why? I'll tell you. Middle two is 75, A4 and A5. Their sum is 75. So it could be 30 and 45, 35 and 40, 37 and 38, something like this. Except beautifully, it's not something like this. It is uniquely one thing. Why? This is 30 and 45. A6, A7, A8 should all be more than 45 or at least 45. Average of the remaining 5, the highest 5 is 38. These two add up to 75. The average is 37 and a half. So if I have even 36 and 39, 4 39s and a 36 will be more than 190. So even if I have 36 and 39, and scenario of 39, 39, 39, 39 into 4, 78 versus 156 plus 36 is 192. It will become more than 190. So even 36, 39 is not possible. Only possible value for A4 and A5 is 37 and 38. Because the average of the 5 largest numbers is 38. And we have to have at least 138 here. I mean, each of this is 38 or more. And this fellow is also 37, just one below 38. So if I have 39, I can have maximum 139. Only one combination possible, 37, 38, 38, 38, 39. That is the other last 5 numbers. Brilliant. It is super useful because we can now attack these things and say, hey, I have A1 to C, I have A1, A2, A3, 37, 38, 38, 38, 39 as my numbers. Brilliant. So last 5 average is 190, middle 2 is 75. These 3 therefore will add up to, all 5 put together is 125. These 3 will add up to 50. 77 plus 78 is 75, 75 plus 50 is 125. These 3 add up to 125. Now let's go to this. This definitely false. The second highest rating obtained is 38. That is not just true. My gut feel is it is definitely true. The lowest rating obtained is 1. Is that possible? I can put a 1 here. 24, 25 in this combo. All my conditions will be satisfied. Overall average 2 for 30, yes. Small phi average 25, yes. Big phi average 38, yes. All numbers integers, yes. Possible. This could be true. I'm not saying it is true. It is not saying it has to be 1. It could be 1. I'm saying definitely false. The third lowest rating obtained is 37. Okay, see they're saying this is 37. That means these two should add up to 13. So I could have 6, 7, 37, 37, 38. Okay, 74, 80, 87, 125. Yeah, these add up to 125. Those add up to 190. Overall 34. Possible. Again, could be true. So let me erase this, start all over again. The median of the 8 ratings is 37.5. It's not just possibly 37.5, it is definitely 37.5. The middle two are 37 and 38, that we know for sure. So this not just could be true, true definitely. Now I'm a little worried. 4 of these things I've said 2 are definitely true, 2 could be true. Last one I need to be able to define it. Let's go. The highest rating obtained is 40. No. Highest rating obtained cannot be 40. Highest rating obtained could only be 39. It cannot be 40. Superb question. The idea that the overall average is 30, the highest is 38 and the lowest is, the top 5 average is 38, bottom 5 is 25. Very interesting. So it narrows down the middle 2 numbers brilliantly. And then we can make a bunch of inferences after that. Or select an integer between x and 40, both inclusive. You notice that the greatest common divisor of the selected integer x and any other integer between 2 and 40, both inclusive, is 1. How many different choices for such an x are possible? So Nice question, but a question that we need to process slowly. Let me put x equal to 2. Is that even possible? Is x equal to 2 a possibility? If I put x as 2, when the second integer is 4, HCF of 2 and 4 is 2. 2 and any other number between 2 and 40 are not coprime. So x cannot be 2. Can x be 3? No, 6 will cause trouble. Can x be 4? 8 will cause trouble. Till 20 is ruled out. Put x as 19, 38 will cause trouble. Ruled out. And so 2 to 20 is straight away ruled out because twice of the number is sitting inside. HCF of x and 2x is 2. And if I put x between 2 and 20, 2x will all be definitely less than or equal to 40. Done. True. I can eliminate everything from 2 to 40. X cannot be any of 2 to 20. X cannot be any of these values. Could x be 21? 21 is 3 into 7. Put any multiple of 3 as other number. 15. It won't work. 22. I put 33. It won't work. Already sensing this beautiful question is basically saying, give me prime numbers. I have a composite number here. 21 is 3 into 7. All I need to think of is there another multiple of 3 in this range? Yes, there is. Done. True. Or list prime numbers beyond 20. 23, 29, 31, 37. 25 and 27 are not prime. 33 and 35 are not prime. 39 is not prime. Any even number I cannot select, I know. I'm going to verify other 25 I cannot select. 25 and 30 will not work. 33 and 22 will not work. So this question is a roundabout way of saying how many prime numbers are there greater than 20, less than 40. A solid trophy consisting of two parts has been designed in the following manner. The bottom part is the frustum of a cone with bottom radius 30 and top radius 30 and height 40. 30, 20, height 40. The moment I have this, I'm straight away imagining this. This is 30. This is 20. This height to this height should be 3:2. This is 40. This is 80. The difference is 40. This overall height should be 3h. This should be 2h. 3:2 ratio. Similarity. Similar triangle. Nothing else. So 80 and 40. Done. I've got this. This is the frustum. While the top part of the hemisphere with radius 20 centimeters, moreover, the flat surface of the hemisphere is the same as the top surface of the frustum. So this frustum, on top of the frustum sits a hemisphere. Obviously, the hemisphere has radius 20. On this frustum sits a hemisphere, like one of those traffic cones, which you find very interestingly. Not the pointy ones, but the nice curved ones. Right? So, interesting. The entire trophy is to be gold plated at the cost of rupees. So it's a trophy. We hold this aloft. 40 per square centimeter. What would be the cost for gold plating the closest? Basically saying, find surface area of this frustum, find surface area of the hemisphere, add those two, find the value in centimeters square, and then multiply that by 40, find a number integer, find whatever you are closest to. Right? Surface area of a cone is pi RL. Of this is going to be pi RL minus this pi RL. I need to find the slant height. This is 20, this is 80. I can find this slant height. This is 30, this is 120. I can find this slant height. I'm having a right angle triangle where if this is x, this is 4x. 20 and 80, 30 and 120. So the hypotenuse, slant height, is square root of x square plus 4x the whole square. This is root 17x. Pi RL minus pi RL is the surface area around the frustum. The flat surface of the hemisphere is the same as the top surface of the frustum. The bottom part is the frustum of a cone with the bottom radius 30 centimeter, the top radius 20 centimeter. Just thinking, I know that I have to paint this surface of the hemisphere 2 pi r square. I've got that. I'm just thinking whether I'm obligated to paint the bottom of this trophy. I'm giving a gold-plated thing. I'm just going to read this again. The flat surface of the hemisphere is same as the top surface. The entire trophy is to be gold-plated. They're making it very clear. Entire trophy. So if you lift it, you look at it from below, it will not be gold-plated. I want that also to be gold-plated. And so there is this circle, there is this, and then there's pi RL minus pi RL. Right? So I'm going to write this as pi RL minus pi RL as a surface around this, plus 2 pi r square, the hemisphere's surface area without calculating the base pi r square, because that is sitting on top of the frustum, so I can't even see it. How will I calculate it? Plus pi r square for this, where r is, capital R is 30, small r is 20, and capital L is 30 root 17, small l is 20 root 17. This is the total area I am color plating, not color plating, gold plating, not color plating anything. I multiply this total area by 40 to get in terms of rupees. Brilliant. So I've got this 30 root 17, 30 into 30 root 17, 20 into 20 root 17. Okay, so if we do this, pi into 30 root 17 minus pi into 20 root 17 plus pi into 20, 2 pi into 20 square plus pi into 30 square. This whole area into 40 rupees is what we need to find. Right, so 900 root 17 minus 400 root 17 pi into 500 root 17 plus 20 square is 400, 400 into 2 is 800, 800 plus 900, 1700 plus 1700 pi by total area. This into 40 is what we need to find. I'm not liking this. It's not giving me any joy to multiply and divide, and it's a pain in the neck, right? So if I have a calculator, I'm just punching in, but I don't have a calculator, so I'm going to do the brute force way. Root 17, 41 square is 1681, so more than 4.1. 42 square is 1764, way more, so 41.2 or 4.12 into 500. So 500 into 4.12, 412 into 5 is 2060. 2060 plus 1700, 3760 into pi, 3760 into 22 by 7, we divide this by 7, 350, 378 approximately, we'll worry about it later on. 378 by 7 was 5 times 35, 28, 4 times 54, so this is 540 into 22. I've overstated by a little bit, I'll worry about that later on. 22 fours are 88, 8, 110, 110 plus 8 is 180, 11880 into 40. My total amount, 2 zeros, 4 8s are 12, 2, 1, 32, 33, 3, 3, 7. I've overstated this. My answer should be a little less than this. Hopefully that's there in our choices. It's not there. 473,000. Yes, it is there. Yes, yes, yes. I'm going for this. Close to this. Pain in the neck. If I had a calculator, I would have been living much happier. And 473. If A, B, C, and C are all positive integers with 4a greater than b, then which of the following conditions is both necessary and sufficient for the expression cube root of 3 power a into 21 power 3a minus b plus 49 power 2b plus c to be a positive integer? But let's simplify this. And so this is 3 power a into 3 power 3a minus b into 7 power 3a minus b into 7 square power 2b plus c whole power 1 by 3. Combine this. So 3 power 4a minus b into 7 power 3a minus b plus 4b plus 2c whole power 1 by 3. So 3 power 4a minus b into 7 power 3a plus 3b plus 2c whole power 1 by 3. 2b plus c, 4b plus 2c minus b, yeah, all good, all good. Right. This has to be a positive integer, which means this should be an integer, this should be an integer, which means 4a minus b should be a multiple of 3, 3a plus 3b plus 2c should be a multiple of 3. Nice. 4a minus b, 3b, 3a plus 3b plus 2c should be a multiple of 3. Straight away I can say these two are multiples of 3, 2c should be a multiple of 3. So first inference I've got c is a multiple of 3. That has to be the case, otherwise our 7 constraint won't work. Okay. So let's look at this. A minus b equal to c, that doesn't help in any form. This won't work. If c were not a multiple of 3, this won't work. This is not a minus b plus 2c. No, it's divisible by 3. That doesn't help. I cannot add everything. That doesn't work. A, b and c are all divisible by 3. That is sufficient. We'll have to think about whether it is necessary. So c has to be a multiple of 3. And then 4a minus b has to be a multiple of 3. Right? If a, b, c are all multiples of 3, we are good. We've already been told that 4a is greater than b. So 4a minus b is greater than 1, greater than 0. So it's not, we're not dealing with a 1 by 3, 1 by 9, that kind of scenario. And so that's ruled out. So this is sufficient. I don't know whether it is necessary. Can I do better than this? Can I be sharper than this? A minus b and c are divisible by 3. Oh yeah, this is beautiful. A minus b and c. 4a minus b has to be a multiple of 3. 3a will definitely be a multiple of 3. I'm going to rewrite this as 3a plus a minus b is a multiple of 3. That means a minus b has a multiple to be a multiple of 3. If a minus b were a multiple of 3 and c were a multiple of 3, we are good to go. This one is sufficient and necessary. If a minus b were not a multiple of 3, then that 3 power 4a minus b will not be an integer. If c were not a multiple of 3, then that 7 power 3a plus 3b plus 2c will not be an integer. The combination cannot work. So this is necessary and sufficient. None of the other conditions. No, this is necessary and sufficient. Answer choice D for delta. Oh, brilliant.
Adu and Amu have brought 2 pieces of land on the moon from Eastor. Both the pieces of land have the same perimeters, but Adu's piece of land is in the shape of a square and Amu's piece of land is in the shape of a circle. So 2 people. So we have Adu and Amu. So Adu's piece is going to be a square. It's a square. And this one Amu is going to be a circle. And given they both have the same perimeter, so let's have the side of this square to be some a. Each side is going to be a. The perimeter of this square is going to be 4a. Let's have the radius of this circle to be r. That means the perimeter of this circle is going to be 2 pi r. So they say like these two are equal. Let's say this is some k. So this 4a is equal to this 2 pi r. Both equal to k. Say that's all. That means from this we can get or we can represent the values of a and r in terms of k itself. So from this what we get, a is equal to k by 4 and from here I get r is equal to k by 2 pi. Done? Clear? Now what is the question? The ratio of the areas of Adu's piece of land to Amu's piece of land. We need to find the ratio of their areas. Simple. So area of this square is to area of this circle. This is what we want. So area of square we know a square, side into side. A we know k by 4, that means a square is going to be k square by 16. This is 2. Here area of the circle pi r square. So pi R we have here, R square, that means k square by 4 pi square, k square by 4 pi square. So, this simplification would give us the answer. So, how can this be simplified? K square, we can cut this, we can cut 1 pi, and we can also cut this denominator numbers. This is 4 ones are, this is 4 fours are, so we are left with 1 by 4 is to 1 by pi, which is same as pi is to 4. So, pi is to 4 should be the answer. Where is pi is to 4? Yeah, we have it, option B. Should be the right answer. We'll check this. Yeah, perfectly right. Option B. Pi is to 4 is the right answer. Ramesh bought a mobile from a local store. He paid 1 by 6 of the price via UPI and 1 by 3 of the price via cash. Let's have the mobile price to be some X. The total original price to be X. So, it's going to pay 1 by 6 via UPI. So, 1 by 6x. And cash, it's going to be 1 by 3x. That means it's paid totally 1 by 6x plus 1 by 3x so far. So, it's going to be 1 by 6x plus 1 by 3x. So, this will give us 1 by 2x, because it's going to be basically 1 by 6 plus 2 by 6, 3 by 6. 1 by 2x is paid. He agreed to pay the balance. So, what about the balance? Well, the balance is going to be another 1 by 2x. So, out of x, 1 by 2x is paid, balance will be 1 by 2x. While paying back the balance amount, Ramesh paid 10% of 10% interest on the balance amount. So, he is going to pay 10% of this money, not this. Whatever is left over, 1 by 2x, 10% of that he is going to pay. That means he is going to pay 10% of 1 by 2x. So, this is going to be 6,000. So, it's the interest paid is 6,000 rupees. That means this is going to be 6,000. And what is the original price? Find the value of x. Very simple, straightforward. It's going to be straightforward. So, from this, what we can understand is 10% of half of x. That means it's going to be like basically x by 20 is going to be 6,000, because it's basically 10%. 10 by 100 of 1 by 2. On simplification, 1 by 20. So, x by 20 is going to be this. X by 20 is 6,000. X is going to be 6,000 into 20. 1,20,000, option C should be the right answer. So, we'll check this. Yeah, right, option C. 1,20,000 is the right answer. The market value of beams made of rare metal has a unique property. The market value of any such beam is proportional to the square of its length. So, the more the length, so whatever the length is, so its value is going to be the price. It's going to be like proportional to, not the length, proportional to the square of the length. So, if it is like the length is going to be, if it is going to be some 10 units, then the price is going to be proportional to 100. So, it's going to be some 100k. So, if the length is going to be some 15 units, then the price is going to be 15 square, proportional to 15 square, 225k. So, this goes like this. So, that's what they are coming to express there. Now, what is happening here? And due to an accident, one such beam got broken into two pieces having lengths in the ratio 4:9. So, total you had some length, it got broken into two pieces 4:9. That means the total length has to be, originally before broken, it's going to be 13 units. Fine, okay. Considering each broken piece as a separate beam, how much gain or loss with respect to the market value of the original beam before the accident is incurred? Fine, okay. Now, this is the original length, which means the original price has to be proportional to square of 13. So, 13 square is going to be 169. So, the original price has to be 169k. K is the constant, proportionality constant. Fine. This is before broken. Now, after broken, we got two pieces, 4 units, 9 units. Now, these are considered to be two separate beams as defined. Now, here 4 square, the price of this piece, this beam is going to be proportional to 4 square, which means 16k. And price of this one is going to be proportional to this one, 9 square. So, 81k. Now, making this total price or total value to be equal to 97k. Right, okay. So, definitely it's a loss. Before broken, the whole price was 169k. After broken into two pieces, it got down to 97k. We need to find how much percentage you are facing a loss. That's a question simply. So, 169k became 97k. That means the loss is going to be how much? 2 and then 7, 72k. 72k from where? From original 169. So, that means the percentage, loss percentage is going to be 72 by 169. K's are getting cancelled, k, cancel into 100. So again, no more stumbling, we'll pull the calculator, get the calculation done, we'll be able to get the answer. So we can do it manually also. 72 out of 169. So I'm going to take it around 170. I'm going to round it off 170. So 72 out of 170. So it's going to be slightly less than half, because for 170 half is exactly 85. It's going to be less than 85, but not much less than, slightly less than 85. So definitely option A is not the right answer. It says gain. B again can't be the answer. No gain, no loss. Can't be the answer. So we are still left with 3 options. Option E says 57 point. It's more than 50, not possible. Very clear. 169, 72 is less than half of 169. Very clear. So answer can't be more than 50. Be somewhere between C and D only. It can't be that less, because this is 72. It should be something lesser than 50 percentage. Means we can now get for D. Again 170, 30% itself will come only closer to 51, 52. That means 30% or 31% can't be. The answer for this one can't be this 31%. So that it's too low, too less. That's why. So 42.60 is going to be the answer. Again, so manually working this, can pull the calculator and get it done very easily. So option D must be the right answer. We'll quickly check this. Yes, we are right. Option D, 42.60% loss is the right answer. For how many distinct real values of x does the equation below hold true? So we need to find out how many values x can take so as to satisfy this equation. So again, we'll go for an empty slide. So we have an equation with that involves logarithms. So it's also given a is greater than 0. Of course, a need to be greater than 0, because we can see a in the base everywhere. So a needs to be positive. Fine, okay, all right. So we'll try to see some ways to simplify and solve. So first of all, we can see all these numbers, they are going to be powers of 2. So we'll take that as an advantage. So we'll rewrite everything as powers of 2. So what happens is, this is going to be x square log of, this is 2 to the power 4, right? So 2 power 4 to the base a. So we know the logarithmic property, power. So power we have, we can take it to the front. So it's going to be that number of times log of that number. So 4 I am bringing here. So this becomes 4x square log 2 to the base a. Okay. By, I can do the same thing here. So this is log 32. Once again, 32 can be written as a power of 2. This is going to be 2 power 5. So log 2 base a 5. I am bringing 5 to the front. Minus, doing the same thing here, 64 is 2 power 6. So this will become log 2 base a power 6, bringing to the front. And here log 32 is 2 power 5, bringing 5 to the front. Great. Minus x is equal to 0. Super. Now what next we can do? Clearly, very easily, comfortably, I can cut all this. Log 2 base a, log 2 base a. They are not going to be 0. In that sense, I can cancel them. So now we are left with 4x square by 5 minus x minus 6 by 5 equals to 0. This is our equation. Simplifying this, or I can multiply by 5 throughout, I will get 4x square minus 5x minus 6 equals to 0. This is going to be a clear-cut quadratic equation. So all I need to do is how many values this x can take. It's a quadratic equation. We are not worrying about what are the values of x. We are only worried about, this question is asking all about like how many values x can take. So we'll quickly check the discriminant of this. Discriminant is b square 25 minus 4ac. So minus 4 into minus 6. So 4, 4, 6, 24, 144. So you can plus 144. So of course 169 is greater than 0. Discriminant is positive, which means this equation will have 2 distinct roots. So x can take 2 distinct values. Option D, 2 is there. 2 distinct values should be the answer. We'll check this. Yes, option D, 2 is the right answer. ABCD is a rectangle where coordinates of C and D are minus 2, 0 and 2, 0 respectively. So ABCD is a rectangle, 2 coordinates, 2 vertices are given, C and D are given. If the area of the rectangle is 24, which of the following is a possible equation representing the line AB? Fine, okay, we'll go for a fresh slide. Okay, yes, yeah, okay. So we'll try to draw this rectangle here. We'll try to first of all fix the coordinate axis. So we'll have the x-axis and y-axis first of all. So x-axis and y-axis, right? Okay, and we'll mark these 2 points C and D. C is minus 2 comma 0. It will be here. It will be here, left hand side. So C will be minus 2 comma 0, and D is 2 comma 0. This will be on the right hand side, again on x-axis itself. So this is D. Fine. Okay, clear. Done. And given the area of the rectangle is 24. Now very clearly CD, we can predict this side. CD is one of the sides of the rectangle. This length, what should be the length? This distance has to be 4 units, because this side it's 2 units, here 2 units, 2 plus 2, 4 units, very simple. Now keeping CD as one of the sides, we need to construct a rectangle whose area is going to be 24. This is what we want. That means how can we form the rectangle? So we can actually form the rectangle in 2 possible ways. So how? One way is I can form above the x-axis, I can form a rectangle like this. Fine, okay, yes. Marking A here, B here. Now this completes the rectangle ABCD. This is one way. This is going to be one side, which is 4. Area is 24. That means what has to be the other side? I mean length and breadth. This breadth is 4 units. Length should be 6 units. 6 4s are 24. That's all. Fine. So is this the only possibility? No. I can also have another possibility. I can form this rectangle exactly below also. I can form points like this. Taking or coming 6 units below, I can mark A, B here. Now here also I can form a rectangle ABCD. Now if we form this way, this is going to be 6. Again 6 4s are 24 is the area. So this way we can form rectangles in 2 possible ways. Now the question is, which of the following is a possible equation representing the line AB? That means AB could be here or here. So we will have to find which one is a possible answer. That's it. Fine. Now we can easily find both the things. This is going to be x-axis. X-axis, the equation is y equals to 0. And this is exactly 6 units away, and it's on the positive side. That means this line has to be what? Y equal to 6. Because 6 units away from x-axis, and at the same time it's on the positive side. And we can also easily recognize this by looking at the points. This where A is going to be 2 comma 6, and this is B minus 2 comma 6. This clearly says that equation of this line AB is y equal to 6. Or if we take here, now A becomes 2 comma minus 6 and B becomes minus 2 comma minus 6. Now what happens to the line AB? If I fix this to be AB, the equation is y equals to minus 6. That means the line's equation would be either y equal to 6 or y equal to minus 6. We'll check the options. So which of the following is a possible equation they're asking? So either one of the two, any one of the two should be here. Yes, we do have y equal to 6, lying in option E. So option E, y equal to 6 should be the right answer, because we do not have y equal to minus 6 or any other lines. Fine, okay. Means this could be the possible answer. We'll quickly check this. Yes, of course we are right. Option E, y equal to 6 is the right answer. So here we have a very long question. Better to go take an empty slide here. Fine, yes. An industrial robo manufacturing company is tasked to design humanoid robots to be used in warehouses where the robot needs to pick items from a stack of shelves. The height of the topmost shelf from the ground is 7 feet. So here is where information starts. So we have robots manufactured in that company. So the height of the topmost shelf is going to be 7 feet. Fine, okay, we'll have a diagram kind of setup. So let this be the ground and this be the shelf. The topmost, this is going to be, the height is going to be 7 feet. Fine, okay. To operate, the robot has to move on a track running parallel to the stack of shelves. So let's have this to be the stack of shelves. 1 feet away, you have a track. In this track only the robot can move. Fine, okay. So this distance is going to be 1 feet. So this is 1 feet. Fine, okay. Yes. That means the robots are going to be placed like this. They will stand like this. So they can access only in that parallel 1 feet distance. That means that they will be 1 feet away from the stack of the shelves. So they will be able to maintain the distance throughout. It's going to be parallel. Shelf and then that robo stack, it's going to be having a parallel distance of 1 feet. Okay, yes. The track is 1 foot away. Okay. Further, the robo cannot raise its arms by more than 60 degree from the horizontal plane. So wherever the robo is there, the robo need to raise the hand. It can go till only 60 degree. So it can be like 0 degrees or maximum 60 degrees. It cannot be going beyond. Anything more than 60 degree, the robo can't raise. That's what they are mentioning here. If the robo's arms are attached to its shoulder, what should be the minimum height of the robo from the ground to the shoulder for its arms to reach the topmost shelf? Very long question, but easy. So we'll complete a diagram here. So this is going to be the shelf. We'll draw the robo here. This is going to be the robo. Considering this is going to be the robo's portion till the shoulders. Now what happens is, from shoulders it can raise the hands, but it's going to be what? This angle can be maximum 60 degrees. It cannot be more than that. So this angle from the horizontal is going to be 60 degrees. And remember, if this is 1, this is also 1. So parallel, right? Yes, 1 foot. Fine. Okay. Question: what should be the height, the minimum height of the robo? So from ground level to the shoulders level, what should be the height? Is the question. So we need to find this height. That's very important. So what are all the things we know? This total height of the shelf is 7. This height is h, according to our assumption, which we need to find. And this horizontal distance is 1. This angle is 60 degrees. That's all. Right. How can we find h? Now complete, use diagrams, use properties of geometry, trigonometry. Done. Fine. So h, if this is h, this again should be h. And what else we know is, here we see a triangle, right angle triangle. It has to be a right angle triangle. If this is 60 degree, then clearly what we can tell is, we can measure the other sides also. It's a 30, 60, 90 triangle. So 30, 60, 90. So we can use trigonometry ratios, or we are well versed in triangles also, reading the triangles. 30, 60, 90 triangle, quick ratio. What should be the ratio? Opposite to 30, if it is 1 parts, opposite to 60 has to be √3 parts. So 1 √3 is to 2, that's going to be ratio, but we are not worried about the third side, the hypotenuse. This 1 is √3. Or we can use the trigonometric ratios. Trigonometric ratios is going to be tan. We can use tan ratio because we are playing with opposite and adjacent. So tan 60 is going to be opposite by adjacent. Yeah, opposite by adjacent. Fine. Yes. So that's going to be what? Tan 60 is √3. Opposite is what we need to find. Adjacent we know it's 1. That means opposite is √3 into 1, which is √3 itself. Finish. So this is anyways √3. Now I need to find the value of h. So what we can do? Very simple. This h plus this √3 is going to be 7. So h plus √3 is 7, meaning h is 7 minus √3. That means the height of the robo from ground to its shoulder level has to be at least 7 minus √3 so as to access this. That's all. So 7 minus √3 should be our answer. We'll just check this. Yes, we have option E saying our right answer. 7 minus √3. We'll check if it is right. Yes, option E, 7 minus √3 feet is the right answer.